Welcome back to The Clean Truth by Roobi.
Glad to be here for this one.
Yeah, we are really excited you are joining us. This is our 21st episode, titled Sustainable Coffee Habits: How Smart Maintenance Reduces Waste and Extends Machine Life.
Which is such an important topic right now, because sustainability isn't only about buying eco-friendly products.
Exactly. It is also about taking better care of the products we already own.
Right, and that ties directly into the concept of sustainable materials management, which really focuses on reducing waste by using resources more efficiently, extending product lifespan and preventing unnecessary replacements.
And when you apply this idea to coffee machines, it makes perfect sense in a very educational, practical way. So many appliances are discarded prematurely because of totally avoidable issues.
Oh, absolutely. Things like mineral buildup from hard water, or just poor maintenance routines, or neglecting regular cleaning.
Yeah, that limescale buildup inside coffee machines is a killer. It can reduce efficiency, it affects the brewing temperature.
It alters the flavor of the coffee, too.
Right, and ultimately it shortens a machine's lifespan if it isn't removed regularly.
But simple maintenance habits, especially routine descaling, really help keep those machines performing efficiently, all while reducing waste and extending the life of the appliance.
Which naturally connects to Roobi's coffee desaler. Having a proper descaling routine supports both better tasting coffee and a much more sustainable use of the product itself.
It is a win-win, really.
It really is. Let's explore how a few simple maintenance habits can keep your coffee machine running longer and reduce waste in the process. And to do that, we are zooming out to look at the macro level. So if you are listening right now, you likely already know the basics of reduce, reuse, recycle.
Yeah, it's a phrase we have all had drummed into our heads since elementary school.
Exactly. But today's deep dive is going to completely change how you view the life cycle of every single object around you.
Your phone, your coffee cup, the clothes you're wearing right now.
By the end of this conversation, you are going to see them through an entirely different lens. Today, our mission is unpacking an official document from the U.S. Environmental Protection Agency, the EPA.
It is titled Sustainable Materials Management Basics.
And it goes significantly beyond just tossing a plastic bottle into the correct colored bin.
It really requires a perspective shift because in a world of constant information overload, we're usually heavily focused on the immediate day-to-day use of a product.
Yeah.
But taking a step back to look at the macro level of how our society handles natural resources is vital for our economic and environmental future, is fundamentally tied to our long-term stability.
Okay, let's unpack this. Before we get into the statistics, and the EPA has provided some heavy data in this document, let's start with the foundational definitions.
Sure.
What exactly is sustainable materials management? Because on its face, it sounds like a very corporate, almost bureaucratic phrase.
It does sound a bit clinical.
How do we define it based on what the EPA has laid out here?
Well, the concept itself is a massive paradigm shift. Sustainable materials management, or SMM, is defined in the text as a systematic approach to using and reusing materials more productively over their entire life cycles.
Over their entire life cycles?
Yes. For a century, we have essentially operated on a linear approach. We extract a resource from the earth, we manufacture something, we use it for a while, and then we throw it away in a hole in the ground.
The take, make, dispose model.
Exactly. SMM demands that we look at that whole timeline and bend that straight line into a continuous loop.
Right. And looking at the text, the EPA breaks down this approach into three main goals. The first one is using materials productively and using less.
Using less is key.
But just to play devil's advocate here, SMM sounds great in theory, but isn't that first goal completely at odds with modern economics? Companies make money by selling us more stuff, not by telling us to use less.
That is the natural friction point, absolutely. But the EPA document addresses this by framing it around productivity. It is not necessarily about halting the economy. It is about extracting more value out of every single ounce of material we do use.
Making the materials work harder.
Right. Efficiency is the starting point. But the second goal actually pushes past the pure economics into something harder to measure, which is toxicity.
Reducing toxic chemicals.
Yes. SMM aims to reduce toxic chemicals and environmental impacts throughout the entire cycle.
So it's not just about whether the final product sitting in your living room is safe to be around.
Correct. It means ensuring the extraction of the raw materials wasn't highly toxic to the local water supply.
Right.
It means the manufacturing process wasn't heavily polluting the air. And the eventual breakdown of the product doesn't leach harmful chemicals back into the soil decades later.
And then the third goal really looks ahead, assuring we have sufficient resources for today and the future. It's the classic baseline of sustainability. Do not borrow from tomorrow to pay for today.
If we connect this to the bigger picture, global competition for finite resources is intensifying rapidly. We have a growing world population combined with expanding global economies.
More people buying more things.
Exactly. As more nations develop and the baseline quality of life improves globally, the demand for physical materials skyrockets. If we rely on that old linear model, we will quite simply run out of accessible, affordable materials.
The text actually mentions some historical data to back that up. It cites an annex to the G7 leaders' June 8, 2015 declaration.
The numbers on that are incredible.
They really are. During the 20th century, global raw material use rose at about twice the rate of population growth. We weren't just multiplying as a species. Our per capita appetite for raw materials was multiplying at an exponential rate.
And that is the core mathematical problem SMM is trying to solve. We became incredibly resource hungry. The document breaks this down into a stark economic statistic. For every 1% increase in gross domestic product, or GDP, raw material use has risen by 0.4%.
So almost 0.5% of extra Earth dug up for every 1% of economic growth.
Precisely. And failing to find a way to decouple material consumption from growth has grave implications for our economy and society. Decoupling means finding a way for the GDP line to go up while the raw material extraction line stays flat or goes down.
Because we live on a finite planet.
Exactly. If we cannot manage that, the environmental costs spelled out in the source material will only accelerate.
And the source is very clear on what those costs look like right now. This unchecked consumption leads to massive habitat destruction and biodiversity loss.
Yeah,
We are clearing out the natural world to fuel this consumption pipeline.
we are.
The text also points to overly stressed fisheries and desertification.
And it's important to understand how interconnected those are. Stressed fisheries are often the result of agricultural runoff creating coastal dead zones. Desertification means fertile land is literally turning into unusable desert because of how we mismanage water and soil.
It's all connected.
It is. The abstract concept of materials management is actually dictating the survival of the ecosystems that support human life.
Here's where it gets really interesting, because the EPA document gives us a highly specific example of this inefficiency, and the numbers are just staggering. Let's look at U.S. food loss and waste.
This is a perfect example of the life cycle perspective.
We have all experienced throwing away leftovers or vegetables that went bad in the fridge. But the EPA zooms out to look at the macro cost of that wasted food.
Right, because when you waste food, you aren't just wasting the final product. You are wasting the massive trail of resources that created it.
That ghost supply chain. Let's really walk through the scale of this because I want the listener to grasp the sheer volume here. In the U.S. alone, food loss and waste essentially wastes 140 million acres of agricultural land.
140 million acres.
Yes. To put that in perspective for you listening, that is roughly the equivalent of planting crops across the entirety of California and New York combined. Just think about the logistics of that. The tractors, the human labor, operating across two massive states, all producing food that eventually just goes straight into a landfill.
It is a staggering inefficiency, and the land is only the first metric.
Right.
The text notes that this wasted food also represents the waste of 5.9 trillion gallons of blue water.
5.9 trillion. And for those unfamiliar, blue water refers to fresh surface and groundwater, the water from lakes, rivers, and aquifers.
Right. In a world where freshwater scarcity is a critical pressure point, draining trillions of gallons to irrigate crops that no one consumes is devastating.
It takes water away from communities for zero societal benefit.
Exactly.
Then there's the chemical footprint. The EPA notes that this wasted food accounts for 778 million pounds of pesticides.
Which is an enormous amount of toxic chemical output.
And it pairs with 14 billion pounds of fertilizer. 14 billion. We are manufacturing chemicals, spraying them onto fields, creating runoff into our rivers, all to protect crops that end up rotting in the garbage.
Which loops right back to those stressed fisheries we mentioned earlier. That fertilizer contributes heavily to aquatic dead zones.
And the invisible trail extends into our energy grid, too. The document states that this food waste squanders 664 billion kilowatt hours of energy.
People don't often associate food with electricity.
No, they don't. But consider the cold chain. We are generating power from coal and natural gas to run industrial machinery, massive refrigerated warehouses, fleets of refrigerated diesel trucks. All that energy is burned to keep food chilled, only for it to be thrown away.
And every single step of that ghost supply chain generates emissions. Which brings us to the final metric in this food waste example. All of this wasted effort releases 170 million metric tons of CO2 equivalent greenhouse gases into the atmosphere.
170 million metric tons. And CO2 equivalent means they are measuring carbon dioxide from the trucks, plus gases like methane released when the food actually rots in the landfill.
That is the overarching insight here. When you toss out spoiled food, you are effectively dumping a fraction of a tractor's exhaust, a fertilizer plant's runoff, and a power plant's emissions into the air.
The physical product is just the tip of the iceberg.
Exactly, which sets up the most critical overarching statistic from the source. This is the number that forces a total perspective shift. Materials management is associated with an estimated 42% of total U.S. greenhouse gas emissions.
42%.
Nearly half of the country's carbon footprint is tied up in the extraction, production, transport, use, and disposal of physical materials.
So it's not just coming directly from people driving cars or heating homes.
No. If we want to genuinely tackle greenhouse gas emissions, we have to revolutionize how we manage the physical stuff that makes up our economy.
If 42% of our emissions come from how we handle materials, we clearly can't solve this just by tweaking the end of the line, which transitions us perfectly into the solution side of the text, the life cycle perspective.
Yes. To address that 42%, we have to look at the major stages of a material's life cycle. The source outlines these clearly. It starts with raw material acquisition, mining, harvesting, drilling.
Right.
Then comes materials manufacture, refining those raw resources. Next is production, the assembly of the product.
Following that is the use, reuse, and maintenance phase.
Which is usually the longest phase.
Right. And finally, waste management. It's like looking at the entire assembly line and the afterlife of a product rather than just the moment you buy it and the moment you throw it away.
Precisely. And the EPA gives a really compelling example of what this looks like regarding product redesign. Imagine a product redesigned to use fewer materials overall.
Okay.
They ensure the materials they do use are less toxic and significantly more durable. And critically, the product is designed to be easily disassembled at the end of its life.
Which is huge because right now, think about smartphones. They are glued together. You can't get the valuable metals out of them easily.
Right. Designing for disassembly means using screws or modular design so materials can flow back into the manufacturing cycle.
But there is a fascinating shift in business relationships mentioned in the EPA text here. It's not just about the engineering. Historically, the relationship between a buyer and a manufacturer ends when the cash register closes.
Yes.
But in an SMM model, a manufacturer wants to maintain a relationship with you, the customer, not just at the point of sale, but through its maintenance and its eventual return at the end of life.
They actively want the obsolete product back.
Because it builds customer loyalty, identifies changing needs, and reduces material supply risk to get their raw materials back.
And that relationship extends backward to suppliers as well.
Oh, interesting.
Yeah, having an integrated life cycle relationship with the suppliers allows for quicker responses to changing demands and collaboratively reducing impacts along the supply chain.
It transforms a transactional supply chain into a sustainable ecosystem. But how do companies actually measure if a new design is better for the environment?
The text introduces a concept called life cycle assessment, or LCA.
Okay.
What's fascinating here is how rigorous this evaluation technique is. LCA allows us to make informed decisions by evaluating the exact air, water, land, and energy consequences of products and processes, and comparing them to alternatives.
So it's like a massive mathematical environmental audit. It takes the guesswork out of sustainability.
Exactly. It provides the concrete data needed to make choices that are genuinely sustainable.
So what does this all mean? If you are prepping for a meeting or just trying to be a more informed citizen, understanding SMM means recognizing that 42% of U.S. greenhouse gases are directly tied to how we manage materials.
It is the hidden footprint of our physical world.
It really is.
And knowledge is most valuable when applied. We encourage you to use critical thinking the next time you make a purchase. Ask yourself about the invisible life cycle behind the object. Where did it come from? What is the actual plan for it when you are done with it?
Just by asking those questions, you start to shift the demand.
Exactly. And this raises an important question.
It really does. If sustainable materials management requires manufacturers to maintain a lifelong relationship with the items they produce, taking them back at the end of their useful life to disassemble and reuse the materials, how does that completely change our concept of ownership?
That is the ultimate question.
Right. In a truly sustainable future, will you ever actually own your appliances, electronics, or clothes? Or will you merely be borrowing the raw materials from the global supply chain until it's time to pass them on? It is a wild reimagining of how we interact with the physical world.
It really makes you think.
Thank you so much for taking this deep dive with us today. We hope this conversation gives you a whole new framework to view your everyday life. Keep questioning the world around you, and we will catch you on the next deep dive.